Okay, so this is an explanation of a little text calendar printer done in Rebel. Sort of a change from some of the other videos which mostly focus on GUIs. This is entirely a console application, so it prints text to the console in Rebel. Starts out with a title, and first line we ask the user what year they want a calendar for, and if that answer, which is assigned to the word year, is nothing, then is empty, meaning that they just pressed enter, then we're going to print the current year and set that year variable, that year word, to the current year. So either way, you're going to see at the top of the screen either the number that was typed in by the user or this current default year, which is the current year. Then we go through a for each loop, and we're going through each of the months in this little set of values in system locale months, which is the names of the 12 months. Going through each of those things, and for each of those months we're doing all this stuff. First thing we're going to do is print the name of the month. So we've got a couple new line characters, some empty spaces, and we position the month basically on that line, a couple spaces in, and a couple more new line characters. So you have the month all by itself in between empty lines, and then we're going to go through each of the days in that system locale days block, and we're going to print the first two characters of the day. So we're going to copy those first two characters and join them with a space. So it'll say M-O-T-U-W-E-T-H and so on, with a space after one. So each of those days on the printed line takes up 3 characters. Okay, so the very first thing we're going to do after that is now we get the what we're doing here is we're going to get the day of the week that we need to start on. The way we're going to do that is first by setting this F variable to this rejoined value. It's going to be the first of current month we're on here in the loop. Current month we're on plus the current year that's selected. We're rejoining all together, so as you know in Rebel you refer to a date value by putting it in that format. The day value dash the month value dash the year value, and then we convert that to an actual date value, so it's not just a string of text but a value which can be computed and evaluated in ways that make sense with days and months by using the toDate function. We're setting that whole evaluated date value to the word F, the letter variable F. And after we're done with that, we're printing a new line, and then we're going to loop for a certain number of times to position the starting number, the number 1, in the right place under one of the days. So, for example, if that day is Monday, we need it right there at the beginning of the line. If it's on Friday, it's going to be a number of spaces over. And the way we're going to do that is we're going to print 3 characters for each item in this loop. And what the loop is we're figuring out the weekday. The Rebel can just figure that out, can figure out for any day ever. You can put this /weekday if you have a date value, and it will return the number of the day of the week. So if it's Monday, that F weekday would be number 1. And if it's Sunday, it would be number 7. So we've already figured out or converted that day to a date value. Now here we're taking the day of the week of that date value and subtracting 1 from it, so that we loop that number of times. So for example, if we have a Monday, we would loop 0 times. We want to put the Monday right at the beginning, so it would be 1 minus 1, which is 0. If it's Tuesday, we're going to do this loop once. We're going to print 3 characters, and that'll move it over so it's underneath the TU. If it, for example, was Wednesday, then our weekday would be 3. It would subtract 1 from that, and it would do this, print 3 characters twice. So now we'd have 6 empty characters, so it would print under Wednesday. It'll do that however many times it needs to for the current week or for the correct weekday of the starting day of the month. So we start there on the line, and then we go through this loop. And we do this 31 times, and what we're just going to do is use this little evaluation here to make us stop before 31 if the month that we're on doesn't have 31 days. So we're repeating 31 times by default. And that day of the week that we started with up here, we assign the value C. If the day of the week, for example, was Monday, that value up there would be a 1, and the C now will be a 2. And what we're going to do is run this little evaluation. So again, we're going to use the variable I to be our iterator here to go up 1 every time we go through this loop from 1 to 31. So on the first day, this stands for 1. So on the very first day, we're going to check to see if this is an actual valid date by using the toDate function again. And toDate will error out if the day that we're putting together by rejoining these values is not a real date. So if we try to do December 70th or, for example, February 30th, we'll get an error when we run that toDate function. And so we're going to tempt that, and the tempt will return a true if there's no error. So if we attempt this and we don't get an error, that means that we're dealing with a valid date, and then we'll do all this stuff. We'll print the date. If that gives us an error, so for example, if we get to February 29th on a non-leap year, or February 30th, or any of these other, September 31st, any days that aren't valid dates, then we won't do this. So we're automatically handling any days which aren't appropriately in a month, and Rebol is just able to figure that out using the toDate function. Okay, so now if we do have a valid date, what we're going to do is we have a little evaluation here. It's a modulus evaluation. We're going to divide a number by 7, and if that's 0, if there's no remainder, then we're going to print a line and then set this back to 1. So what's actually happening here is, imagine we are on say we're on a Sunday. So we're on a Sunday. That's the 7th date, or sorry, the 7th position in the week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. It's the 7th of those positions. So this would evaluate to what actually happened here is we've added 1 to the date. So that C now would be 8. C minus 1 would be 7. Divided by 7 is 0, it has a remainder of 0. So if that's the case, if we've gotten to the end of the line, we need to print a new line, and then we need to set that counter back to 1. Okay, so it's no longer 8; it's going to be set down to 1. So that just prints us a new line every time we get to Sunday, and then we print that date. But we're going to print it with some extra space here. If you imagine, some of these dates have 2 characters and some of the numbers have 1. So if we're printing February 9th, it's going to have 1 character. And remember, each of those days of the week takes up 3 characters. So if the length of that date that we're printing is 1, then we're going to add 2 characters here. Otherwise, we add 1 character. So if we're printing like February 9th, we would print a 9 in that February month, followed by 2 spaces. That'll move us along to the next day. If we're printing February 12th, we'd add 1 space. So again, that would move us along to the next day. We print that together with the date, and we just continue to do that until we get to 31. The key here being that we need to, every time that counter gets up to 8, we need to print a new line, and then set the counter back to 1 and keep doing that. So this is what formats the lines for us. We've started on the appropriate and the appropriate space up here. And then we've just gone through after that and watched whenever we get to the end of a line, we print a new line, and that's it. So that gives us this little app, asks us to run. What do I do here? Okay, so if I just press enter, it's going to give us the year 2017, and it goes through, and there we go. We've got all of our months. So you can see I typed in 2017, or no, I didn't type in 2017. It printed that out, and then we had a month with some empty space around it. Here we printed out all the weeks, or I'm not all the weeks, all the days of the week for that month, just the first 2 characters of each day. We printed out the space we needed to get this first number on the right, underneath the right day of the week. We put an extra space there to get it, extra 2 spaces actually, after Saturday to get it under Sunday. And then we went along, in that loop, counting from 1 to 31. When we got to the 7th position, started a new line, kept printing. When we got to the end here, and that modulus was 7, we went back to the beginning and did that until we got to the end. You can see for February it stopped on 28. And if we put in the leap year, rebol will know that, it'll automatically do 29. And so we have everything we need for all of these months. If we run it again, you can see we'll get that for any month. I know that the year that Columbus discovered America was a leap year, so let's do that. We'll do 1492, and there we'll get a leap year. In February, you can see we have 29 days in February. And you can check this. You can check, for example, the day you were born, or just print out a nice calendar for the year to know what date you're on. That's it. So a little bit different than some of the other little simple GUI examples. This gives you an idea how you can use loops and variables and some of the functions for handling data types in rebol to do useful things.